Welcome to Topic Wise. Here we are going to solve one numerical on mirror combination. Our problem is an object is placed in front of a convex mirror at a distance of 50 centimeters. A plane mirror is introduced covering the lower half of the convex mirror. If the distance between the object and plane mirror is 30 centimeters, it found that there is no parallax between images formed by the mirrors. The radius of curvature of the convex mirror is. That is our question. Better we solve this numerical by using the ray diagram. Here this is convex mirror, and from the given data, object is in front of the convex mirror at 50 centimeters distance. So distance between object and convex mirror is the 50 centimeters. And one plane mirror is introduced between the object and the convex mirror at the lower half of the mirror. And what else given? The distance between object and plane mirror is the 30 centimeters. That is given in our problem. And from that, now distance between the plane mirror and convex mirror is 50 minus 30. That is equals to 20 centimeters. And we had to find out the radius of curvature of the convex mirror. So first we start the image formed by the plane mirror. Plane mirror always forms one virtual image which is equal distance of the object distance. So distance between the plane mirror and object is the 30 centimeters. So now plane mirror can form one image 30 centimeters away from the mirror, that is inside the behind the mirror. So this is the location of the image formed by the plane mirror, that is 30 centimeters from the plane mirror. 30 centimeters from the plane mirror, that is nothing but 10 centimeters from the convex mirror, because of distance between the plane mirror and convex mirror is the 20 centimeters. So distance from the object and the image of the convex mirror is 10 centimeters. And here this is the ray diagram for image formation by the convex mirror. So these two images have no parallax, that is given in our problem. That is, both they viewed at the same point when we observe from the different positions. So image formed by both mirrors is at this point. So now distance between the image and pole of the convex mirror is the 10 centimeters. Now let me write the data, given data from this problem. That is, what is given here? First, object distance u. Object distance is equals to, that is 50 centimeters. But that is in front of convex mirror, that is left hand side of the convex mirror. So that is negative sign. And image distance of convex mirror is equals to 10 centimeters. But this is inside the mirror, virtual image inside the mirror, that is right hand side of the pole. So that is positive. And what we had to find out? A radius of curvature. This is unknown data. R is equals to how much? Here we had to use the formula to find out the R. That is, R is equals to twice of focal length. But we don't know focal length of the convex mirror. To find out the focal length of the convex mirror, here we have to use the mirror formula, that is 1 by F is equals to 1 by V, where V is the image distance, and plus 1 by U, where U is the object distance. Now substitute the known values in this formula, that is V is equals to 10, 1 by 10, plus U is minus 50, and here 50 is LCM. So 50 is equals to 5 minus 1, that is equals to 4 by 50, that is f is equals 1 by f is equals to, from this f is equals to 50 by 4, that is equals to 12.5 centimeters. That is positive sign, that is focal length of convex mirror is always positive. So from this r is equals to twice of focal length, that is 2 into 12.5, that is equals to 25 centimeters. So our answer, radius of curvature of convex mirror is equals to 25 centimeters. This is our answer. Thanks for watching.